aim it at the
I made
board
this
right
for
here.
you. Okay.
Put it on your table so you can write. All right. Here we have another note to make, and I was wondering, and I'm sure you were as well, when is the object that we just looked at speeding up, and when is it slowing down? So we're going to answer that question together. And the way we're going to do that is we're going to do an acceleration velocity mapping of this curve. So on the top of the curve, I'm going to map acceleration. So put a little a somewhere at the beginning of your curve above. A. Put an A right there. All right. Now, I'm going to map whether acceleration is positive or negative as I go around the curve. And I can tell by not drawing every tangent in the physical, but mentally I'm going to draw tangent lines along this mountaintop. And when they're leaning this way, I'm going to say positive. When they're leaning that way, I'm going to say negative. So as I start, do you see like the tangent line? We actually had one somewhere in that area where time was what, 2? 3? Okay, so we had a positive. What about here? Do the mapping for me. Alex, what about here? The tangent
A
line.
5?
Pardon?
A 5?
Yeah, so anywhere in this area, is it going to have a positive tangent? Or
Yes, positive.
it is?
Yes.
All right, what about here, Alex?
Same still.
Here?
Yeah, same.
Here?
Same.
And what about here?
No.
Right before here. Right here it's 0, so I'll
Zero.
just put 0.
And after that's
0
negative,
is
so
not
go back down.
positive or negative, so it
Yeah,
doesn't
zero is zero.
count. All right, coming down the mountain then,
They're all
Alex.
negatives.
All right.
Negative, negative, negative,
All right.
negative, negative, negative.
All right, so that's my acceleration map. Make sure yours is mapped out as well.
Yeah.
Now I'm going to do velocity under the curve. It doesn't have to be under an acceleration above. That's just how I chose to do it. So velocity is not a slope on this graph. It is just the value. And over here, I read the values of velocity. So I notice around 2 seconds, my velocity is also at 2. So that's a positive number. And then I look at velocity at time equals 4, somewhere in here. And velocity is almost 4. So is there any negative velocities at all on this graph? To me, it looks like they're all positive numbers over here on my scale. On my vertical scale, the numbers for velocity go from 0 to 26. There are no negative ones. So velocity is going to be easy to map. Put in positive signs all the way around. Alright, so do you see where I got the positives? Put in the positives for velocity. So now we're ready to answer this question. Where is it speeding up? Well, it's speeding up where the signs of velocity and acceleration are the same. So they're both positive or they're both negative. So right here in this area, they are both the same. So that goes from time equals 0 to what was right under the mountain? I forget. 9. Time equals 0 to 9 seconds. The object speeds up. How did I know? Their signs were the same. So afterwards, you'll notice one's positive and one's negative. So in my color coding here, I'll switch to blue. Now on this side of the graph, the signs are different. So therefore, from 9, time equals 9, to, where does it end? 15? 15 seconds, the object slows down. Were you wondering why I didn't have you do a finger map of this object? You were. Remember, we always did our little finger map?
Yeah.
Why didn't I ask you to do one here? Brandon, what were you going to say?
Oh, I was gonna ask a question.
Okay, go ahead.
So I get they're supposed to do that, but why is the velocity going on the downward slope? Why is that positive?
What, say, which one don't you understand why these
The
velocity is
positive,
positive? When we're looking for velocity on a velocity graph, we do not look at the slope. We
Okay,
don't,
so
we
just
look at
because-
these numbers. these
since they're
numbers
all
and
positive-
notice what kind of numbers are over
They're all
here.
positive, 'cause it's not below the line.
Right,
Okay.
exactly. All right, the student becomes the teacher. All right, let's go ahead and look at why. I forgot my question now, Brandon. What was
I know
it?
you were asking
About the, why you didn't
Why
do the
did
finger
you
thing?
yes, the finger thing. The finger thing.
What?
Why you didn't do the finger thing?
Why did I? Yeah, I knew it was a thought going in my little head. All right. Why am I not asking you to do a finger map? Because it's kind of hard to do because we don't have position here. We have velocity. So you start somewhere in your finger map starting spot, and then all we know is it's speeding up and then slowing down. So it's hard to do. Try it. Put your finger in the air, and the only thing you can say is it's speeding up and then slowing down. It didn't even change directions because the velocity is always positive, so it's going in one direction. So can you go fast
One
and then
direction,
slow? That's all you can do. Not a very easy or interesting finger
Go in no
map.
direction.
Right.
Womp
We'll
womp.
end our discussion
Subsidy.
today. I bet you were wondering as well.
What a new cyber.
Were you wondering what's the area under a
Yeah.
velocity versus time graph? What is the area under it? So I'm actually going to clear the board. Clear the board.
You're doing this in math class and I don't like it.
And I'm going to give you a different velocity versus time graph, which is not on your notes, but if you would add it, do you have some room? Velocity versus time. Velocity in meters per second, time in seconds. And I'm going to draw this map. So let's say that happens at velocity equals 6, and it goes on till 10 seconds. So it is just a straight line. So someone, after you sketch that very interesting velocity versus time graph, you sketch it, you have room to sketch it on there?
Well, I'll sketch this little graph thing.
Yeah, just sketch that graph. It has a velocity of 6 for the whole time. So the velocity is constant. But this will help us answer this question that is plaguing us. What is the area under the velocity versus time graph? What does the area under it represent? There's another quantity, or that it does. So Brian, you have your sketch?
Oh, so could I
We're putting down that little
Yeah.
number, this little 5-minute bell. Perfect timing. This is my last or last point probably for today. So we have a constant velocity of 6 for 10 seconds. That's all that's saying. And I'm wondering about what is under here. I picked this graph because it's geometrically possible to find the area. It's going to be length times width. So I get a 6 by 10. 6 times 10 is 60. And I'll put a little decimal point there so I can use sig figs of 2. All right, 60. And what's the unit when we do area? Zach, do you recall how it would work? If you have this times this, which is what we did to find the area. Watch, this time it's meters per second times seconds. The other one was rise over 1. It was meters by second divided by seconds. But this, when we're finding area, it's length times width. So we have unit times unit. So it isn't meters per second squared. It's just meters. All right. So this is 60 meters. What is that? Is that a velocity? What's 60 meters? What kind of quantity is it, Brandon?
Distance.
In which we've upgraded to not
Displacement.
displacement. Weep, everybody. Weep. Do you see what I'm saying? You take the slope of a displacement versus time graph and you get velocity. You take the slope of a velocity versus time graph and you get acceleration. The area under a velocity time graph is displacement. It's just a beautiful thing. Weep. Okay. All right, that's our last point for today. We have a couple OYOs we can try that reflects this material. I think it involves a graph. So if you look on the back of your handout, you'll see
Oh.
1.1, what's that, 1.11?
That was just 2 to do. Thank God. Praise the Lord.
1.12.
I think so.
So let me look at
Think
those and
16
see
was
if
out?
we're really ready for them. I think we've covered everything. Yep. We can do 11 and 12. And let's see if it goes on. That's the last ones in our mod. Okay. That's all. Your homework is OYOs 1.11 and 1.12, best calculated on the graph on the back of your sheet. I have one more point to make tomorrow that will involve that little one, and then we're done and we're ready for review. So, I didn't talk about the lab because I wanted to finish this acceleration blab, and so we'll have some lab blab tomorrow. All right? Questions on what I said today or what's expected tonight? Hunter, see you soon, I hope. Over and out.
Bye, Hunter. Everyone say bye.
After school. What's in for no reason?